Hello students, in this video we're going to multiply two matrices and we're going to consider A times B and B times A, and we're going to discover that you can't always multiply two matrices, for one thing. Another thing we're going to discover is that matrix multiplication is not commutative, that in general A times B is not equal to B times A. While that may be true sometimes, it is not always true. So you'll often hear it said that matrix multiplication is not commutative. That means people say, oh, if you have two matrices, then A times B is not equal to B times A. What they really mean is it's not true in general for all cases. Right, without further ado, here we go. So if we're going to multiply A times B, if you look back to my video on the dot product from a linear algebra perspective, then you'll see the same concepts being applied here. So here I have the matrix A, which is 2 by 2, and the matrix B, which is 2 by 3. And I'm going to multiply the two of them. Now, look at the number of columns in A and the number of rows in B. Notice that they're the same number. That means that these matrices are compatible, and the result will be, after multiplying, A times B will be a 2 by 3 matrix. Let's take a look. So here I have A times B, and I just put them in the proper order. I put A first and B next. That's very important. And then when I'm about to multiply them, I'm going to set up the dot product of the row here of A, and that's a minus 3, 5. So notice that I put the top row of A there, minus 3, 5, minus 3, 5, minus 3, 5. And I put the bottom row of A, minus 5, minus 1, minus 5, minus 1, minus 5, minus 1. So I'm thinking of these as row vectors, each of the rows of A. And now I'm going to perform this dot product between the top row of A and the first column of B. And then the bottom row of A and the first column of B. And then I just proceed along. I take the top row of A, first row of A, and I dot it with the second column of B, and I take the second row of A and I dot it with the second column of B, and then likewise I take the first row of A and I dot it with the third column of B, and I take the second row of A and I dot it with the third column of B. And each of those dot products was perfectly compatible. 2 by 2, 1 by 2 and 2 by 1, 1 by 2, 2 by 1, 1 by 2, 2 by 1 for each of the entries. And then I just perform the multiplication and the addition. So I just perform the dot products for each of those entries and we get A times B. Now if I tried to multiply B times A, I would be unsuccessful, because while B is 2 by 3, it has 3 columns. A is 2 by 2 and it has 2 rows. So that dot product is not going to be compatible when I try to do the multiplication. So if I set up the, once again, the row, I'll just look at the first entry. Let's just look at the row of B. The first row of B, it's 1, 5, 2. And then when I multiply that by the first column of A, let me put a minus sign for that column, sorry about that. Then I see that while I have numbers to multiply here in the first two parts of the sum, A doesn't have that third component that I need, because this number is not a 3, it's a 2. So these matrices are incompatible, and we see that A times B is not equal to B times A, because B times A is not a compatible multiplication. So you cannot multiply B times A. And then in general, we say that A times B is not equal to B times A for matrix multiplication. All right, so that's how you multiply two matrices. First, look for compatibility. Can you even multiply them? Think about what the resulting dimension is going to be. Do a little sanity check. It's supposed to be 2 by 3. Sure enough, 2 rows by 3 columns. And also, now that you're anticipating 2 by 3, perform the respective dot products. The matrix on the left will be the rows, and the matrix on the right will give you the columns. You match up the respective columns with each of those rows. Okay, good luck.